We have here, it says, you see all of your properties that's listed. It says here, example 3, use the properties of exponents to simplify the expression. Write with positive exponents. So that means that our answers, our exponents need to be positive. It says assume that all variables represent positive real numbers. So we want positive exponents here. So let's look at our first example. We have here example A. We have x to the 1/3 times x to the 1/4. Going back to what we know about our properties here. We have a common base. What are we going to do to the exponents? Add. You can write it down, but we're going to add. You're saying here, x. Let me see something here. That's too dark. It's that glare here. All right, so you're saying x to the, cut it back on. Yeah. All right, so let's see. You're saying x to the 1/3 plus 1/4. Now, please, we're using our exponent rules, yes, but now we're using our fraction rules. Adding a fraction doesn't mean when you're taking 1/3 and you're adding it to 1/4 that is 2/7. One rule doesn't fit all, okay? You know, so what do we know about fractions when the denominators are not the same? LCD, right? Okay, so we need to convert these. Now, you can use your calculators. You can put in 1/3 plus 1/4. I'm not going to go through the whole step-by-step stuff. I'm just going to go ahead, because you have a calculator, you can do that, okay? So, we want to convert 1/3 and 1/4 into 12ths. So when we convert 1/3 into 12ths, that becomes 4 12ths. And convert 1/4 into 12ths, that becomes 3 12ths. Now that we have a common denominator, we have x to the rule says, and this is our final answer, is not 7/24. The rule says once you convert, keep your denominator the same, add the exponents. Add the numerator. Here we go. So we have 7/12, and that is our answer.
I thought you timed the 3 and 4 into 12. Get rid of the fraction.
We're not getting rid of the fraction. No. We're not multiplying. We're adding the exponents. So no. All right, here we go. B, we have 9 to the 2/5 all over 9 to the 12/5. So just imagine that these were not exponents, and think about it. You have a common base. They're raised to a power. What are we going to do to the exponents when it's a quotient? Subtract. So you're saying 9 to the 2/5 minus 12/5. That's what you're saying. You're going to bring up that exponent that's in the denominator and subtract it to the exponent that's in the numerator.
Question.
Yes.
Why is the 9/9 not converted to 1?
Because you're keeping your base the same. Okay, that's number one. Now let's just go back to if these were not the fractions were not, the exponents were not fractions. And let's just say that it said 9/2 or 9 squared and 9/12. That means you have, if I told you to expand this out, you're saying you have 2 factors of 9 over 12 factors of 9. We don't just automatically divide out the 9s. You got it? Okay. Keep the base, write it down. With the exponents, you're keeping your base the same.
they're gonna be different?
If they're different, we can't do anything to the exponents.
Okay.
Because the rule says the base have to be the same in order for you to add or subtract them.
Okay.
Okay? All right. Now, with our exponents here, 9 over 2/5 minus 12 over 2/5, we do have a common denominator. So we don't have to come up with an LCD because we have 5. We know how to, when you have a common denominator, the rule says bring together your numerators over the common denominator. So you're saying 9 to the 2 minus 12, which is what, negative 10 over 5. And as with all fractions, if it's an exponent or not, we need to reduce it. Negative 2. And it says here, your second sentence, write with positive exponents. That's 9 to the negative 2 power. How do we make it positive?
1 over 9 over 2.
Flip. If I can flip, I would flip. 1 over, base stays the same, the exponent becomes positive. We have 1 over 9 squared, and then 1 over 9 squared gives us 1 over 81. Letter C, we have 11 to the 2/9, and then all of that is cubed. We have a base that's raised to a power, and then that's being raised to another power. Power to a power. So what are we going to do to the exponents here? Multiply, yes. 11 to the 2/9 times 3. That's what you're saying. You're going to multiply the exponents. So what do we know about 2/9 times 3? Can we make this 3 into a fraction by placing a 1 under it? Can we do some cross reducing? 3 and 9? 3 goes into 3 once. 3 goes into 9 3 times. And we're left with 11 to the 2/3 power.